Good day, everyone. My name is Olabiadeno, and I'm representing AgriHealth, my solution for the Africa Deep Tech Hackathon. And AgriHealth is a tool targeted at SDG 1 and 2, no poverty and zero hunger, respectively. And it's a tool that provides farmers and agricultural stakeholders with a method to perform predictive analysis to safeguard the health of livestock and crops. So the idea is with a solution in place that can effectively analyze if a product is diseased, be it a livestock or a crop product. Predictive maintenance can be done to ensure produce are not lost to diseases when it affects other crops and livestock. I'll be demoing the crop aspects of the solution, and we currently have the corn model done, the maize model done, and also the poultry model for the livestock done. To test this, you just need to click on this URL that takes you to the link of that host data set that was used to train these models. So I'll be testing the corn model, and this is the corn model, and this is a sample disease that affects corn in Africa, the Seposa leaf spots. So I'll be saving this image, save this as the test Seposa, and then to save time also, I'll go back to corn and also pick an LD image of the corn, and I'll select, okay, let's go with the last image of the corn. So I'll save this as the LD image, and then we can save this. So I'll come back here, and to use this, you just need to select the classify image option. We have the real-time classification. This is aimed at areas where there is enough internet connection. Users can just select the real-time classification, take a picture, and get an analysis immediately. But for cases where there's no access to internet, you can take a picture, and then when there's internet connection, you can just follow this process to upload the image that you took, and then get your analysis. So the first we are testing is the test Seposa. So the image is getting loaded in, and once the image is loaded in, we'll first see the prediction by the model. So we have a correct prediction, and this has shown that this is the Seposa leaf spots, and then we immediately generate an analysis on how you can mitigate this to ensure that it does not affect other crops that you have. So let me take this away, and then let's test the LD image that we have selected earlier. So this is the LD image, open, and then once this image gets loaded in, ideally we should get an inference that tells us that this is an LD image and you don't have to do anything. Yeah, so we got this correctly, and this is an LD image. We still generate an analysis to just show things that you can just do generally, but we don't give any direct analysis for preventive measures because there was no disease. That's basically the demo. So I'll just be talking briefly about the possible use cases. So this is like, there's a simple mobile device integration or a web integration like I've just demoed. And for on a large scale and a more mechanized method, we can have the drone tech or cameras mounted at different positions in a large farm. And then these drones and webcams can be used to repeatedly take pictures or videos that can be monitored constantly. And immediately a detection is done, a notification can be sent to the stakeholder in charge of maintaining that. And that way, this preventive measure can ensure that less produce are lost to diseases and pests. Thank you.